Our sun, a celestial inferno, is both life-giver and a potential harbinger of chaos. Solar storms, powerful eruptions from the sun's surface, are a stark reminder of this volatility. These events can unleash massive amounts of energy and particles towards Earth, posing a significant threat to our technology-dependent world. Imagine a world without electricity, GPS, or satellite communication. This is not science fiction. It is a potential consequence of a major solar storm. At the heart of these solar storms is a star in constant turmoil. The sun is a giant ball of plasma, a superheated state of matter. Solar flares are sudden, intense bursts of radiation from the sun's surface. Then there are coronal mass ejections, or CMEs, colossal eruptions of plasma and magnetic fields. Solar energetic particles pose a radiation hazard to astronauts and spacecraft. Twisted magnetic field lines can snap and reconnect, releasing energy. When a solar storm erupts, it can send a barrage of energy and particles towards Earth. Our planet's magnetic field, a protective shield generated by Earth's molten core, deflects most of this onslaught. However, intense storms can penetrate this defense, leading to a geomagnetic storm. Imagine this as a cosmic shockwave disrupting Earth's magnetic field and sending ripples through our planet's upper atmosphere. One of the most significant impacts of these geomagnetic storms is on our power grids. The surge of electrical currents induced by these storms can overload transformers and power lines, leading to widespread blackouts. Satellite communication systems, vital for navigation, communication, and data transfer, are also vulnerable. The increased radiation and charged particles from solar storms can interfere with satellite signals, causing disruptions and even permanent damage. Air travel, particularly at high latitudes, faces risk from solar radiation. During a solar storm, the radiation levels at high altitudes can increase significantly, posing a health hazard to passengers and crew. Astronauts working outside the protection of Earth's atmosphere are even more vulnerable. Exposure to high levels of radiation can lead to radiation sickness and increased risk of cancer and other health problems. Section 4. Shielding our world, monitoring and mitigation. In the face of these cosmic threats, we are not defenseless. Scientists around the world are constantly monitoring the sun's activity using a fleet of spacecraft and ground-based observatories. These solar sentinels provide us with early warnings of solar storms, giving us crucial time to prepare. Space weather forecasting, akin to terrestrial weather forecasting, is becoming increasingly sophisticated. Scientists can now predict the likelihood and intensity of solar storms, allowing us to take proactive measures to mitigate their impact. Power grid operators, for instance, can adjust grid loads and implement protective measures to reduce the risk of blackouts. Satellite operators can put their spacecraft into safe modes, minimizing exposure to harmful radiation. Technological advancements are also playing a crucial role in enhancing our resilience. Developing radiation-hardened satellites, designing more robust power grids, and improving space weather forecasting models are all essential steps in the right direction. International collaboration is paramount in this endeavor. Sharing data, expertise, and resources allows us to better understand and prepare for the global impacts of solar storms.